Okay, grade 9 review of algebra. Chapter 8 is what we're starting. Welcome back from a 2019. 2 weeks of eggnog and turkey, and your brains probably have gone completely to mush. But as we go through these questions, listen to the explanations of what parts are which and why you do the things you do with opposite operation to solve. And use this as a review because I think in 2 days you'll forget these questions anyway. And you can try these questions again to make sure you understand what procedure you're supposed to employ. Your first question is x minus 4 equals negative 2. Now, if we were to draw this, what you did in grade 8 and grade 7 was you said, well, this represents an x, and those represent negative 4, and those represent negative 2. And in order to solve this, you learned that if you add 4 to here and add 4 to here, visually you understood that that maintains balance. But over here, because it made a zero pair, and because those made a zero pair, you ended up with x equals a positive 2. It's supposed to be a positive there. But over here, what I would do is I'd add 4 to both sides, and I'd put my line through it just like I did here. And I would say x is left, and 4 positives and 2 negatives combine to make 2 positives. And I have my solution of x equals 2. This negative 4 is called a constant. And in two-step algebraic equations, it's usually easiest to get rid of your constant first by adding or subtracting an opposite amount to both sides. In the second question, your constant is right here. Okay, so your constant is this. Now, if we were to draw this, we'd have 2, and we'd have a negative x. This negative symbol is still a part of your coefficient. So it's a negative x equals negative 5. So pictorially, I would put negative 2 on both sides to get rid of my constant. Or numerically, I would put a negative 2 on both sides to get rid of my constant. Now what's important to realize is when you get rid of your constant, you do not have x. You still have a negative x equals negative 7. Because there are no zero pairs here. But we're not done. Because this negative x right here is the same thing as saying negative 1x equals negative 7. So what we would have to really do here is divide both sides by negative 1 to get rid of your coefficient, and x would equal a positive 7. Another way to think about that is you can, as if we employ our opposite of, we can say the opposite of x. The opposite of x is negative 7. So therefore, x must be a positive 7. Our next question, our constant this time, or our plus minus value, is a decimal, but it's still our constant. So in order to get rid of it, I'm going to subtract 1.5 from both sides. Now here we have 0.2 positives and negative 1.5 negatives. Which do I have more? If I have more negatives, how many more? I have negative 1.3 more. X equals negative 1.3. In our next question, our constant this time is on the right, but it's no problem because if I was to draw it, it would be 4 equals negative 3 and a positive x. So I would still add 3 to both sides to get rid of the constant. So I'm going to add 3 to both sides. Whatever you do to one side, make sure you do to the other. And x will equal 7. Now we have an equation where there is no constant. There is just a coefficient. And if I was to draw it, it would be 2x's is equal to 7. Okay? And if 2x's are equal to 7, then each of these x's is equal to 3.5. What I would do numerically is divide both sides by 2, and I would end up with x equals 3.5. In our next question, negative 3x equals 12. Okay, those are positive, not negatives. What I would do is I divide these negatives into 3 piles, or 3 scales. And I would take these 12 and divide them equally onto the 3 scales, and I'd have a negative x equals 4, or a positive x equals negative 4. If the opposite of x is 4, then the x must be equal to negative 4. Algebraically, through opposite operation, I would divide both sides by negative 3. Not by positive 3, but by negative 3. And x would equal 12 divided by negative 3, which is negative 4. Obviously, opposite operation is much faster and more efficient than modeling. But either way, you get the same answer of x equals negative 4. Here we have a quarter of x equals negative 2. So another way I could write this exact equation is this. Right? A quarter of x equals negative 2. If I was to draw it, that's x. I only have a quarter of x equals negative 2. And if a quarter of x equals negative 2, if I was to quadruple this, and I'm going to try my best to quadruple it, I'll take this one here. I'll infinite clone it. Double it, triple it, quadruple it. If I was to quadruple that side, I would also have to quadruple this side, so it was negative 2. So I'll have to quadruple it. But these 4 quarters of x, when combined, would make a full x. And over here we'd have negative 8. And therefore x equals negative 8 from a modeling standpoint. Okay, so if a quarter of x equals negative 2, and if I quadruple both sides, it should maintain equality. And x would equal negative 8. That's a lot of drawing to do. Numerically, what we did here, since we quadrupled it here, we quadrupled each side. We're going to express that mathematically by multiplying both sides by 4. Whatever I do to one side of an equation, if I do the same thing to the other, it maintains equality. Multiplying a quarter of x by 4 gives me a full x. And multiplying negative 2 by 4 gives me negative 8. And my solution is x equals negative 8. Next question. Now the problem with this one is it's a negative half of x. And if I was to draw it, we always had a hard time taking this half of x and saying, well, this is not half of x, it's a negative half of x. So when we got to this point, we said, well, you know what, we're not going to bother modeling it. But we realized since this says x divided by negative 2 is equal to negative 4, then multiplying by negative 2 is the opposite operation. Right? We could do it that way if we wanted to think of it that way. Or, conversely, I could say a negative half of x could also be expressed this way. Those are the same thing. So a negative half of x can be expressed either as it's written in black or as it's written in red. They're both the same equation. Since dividing by negative 2 and multiplying by negative 2 are opposite operations, if we do it to both sides, we cancel the operations out, leaving us with just the x equals a positive 8 as a solution. Alternatively, if I had interpreted it this way and I divided both sides by 0.5, negative 0.5, and took my calculator, and said, what is negative 4, or just what's 4 divided by, I got a new calculator here, 0.5, the answer is 8, and since a negative divided by a negative is a positive, our answer is positive 8. Now we get into two-step equations. So what that means is we have both a constant and we have a coefficient. And when you have a constant and coefficient, in grade 7 and in grade 8, you learned the easiest way to isolate the variable is to get rid of the constant first, which means we will add 1 to both sides, leaving us with 2x equals 4. Now we're left with just a coefficient of 2 or a multiplier of 2. So the opposite of multiplying is dividing. And x will equal a positive 2. That's a grade 7 question. A grade 8 variation is where you have a negative coefficient, but the same thing is true. We still have a constant. We still have a coefficient. The first thing we should get rid of is our constant. So I'm going to subtract 1 from both sides first. Leave it with negative 2x equals negative 4. To get rid of the constant of negative 2, I'm going to divide by negative 2. And x will equal negative 4 divided by negative 2 is a positive 2. X equals positive 2. Again, a two-step equation you would see in grade 7. We have a constant. And our coefficient is a fractional coefficient. It's actually a half coefficient or a half coefficient, but we write it as half of x using the black ink there instead of the red ink, but they all mean the same thing. So I'm going to add 3 to both sides. And in doing so, I'm left with half of x is equal to 4. And if half of x is equal to 4, then multiplying both sides by 2 will tell me that all of x is equal to 8. Our next question, again, similar to the last one, it's a grade 8 variation. We still have a constant and a coefficient. This time our coefficient is a negative quarter of x, or a negative quarter of x, or a negative quarter of x, but we write it this way because it's the cool way of writing it. But all of them mean the same thing. So the first thing we're going to do is get rid of the constant by applying the opposite operation. So instead of adding 2, we're going to subtract 2, leaving me with a negative quarter of x equals negative 8. And if I multiply both sides by negative 4, that's the opposite of dividing by negative 4. I'll leave myself with x, but if I do it to one side, I do it to the other. And a negative 8 times a negative 4 is a negative 32. No, it's positive 32. Thank you. You are on a roll. 4 in a row. Nice. Now our next question, you learned in grade 8, it's called distributive property. And I want to draw it first because I think it's important that we know what it means. So this says 2 groups of x plus 1 is equal to 10. So 2 groups of x plus 1 is equal to 10. So if I was to draw that, this is one group of x plus 1. And if I multiplied it by 2, or doubled it, 2 groups of x plus 1, it would look like this, equals 10. All right? Now, since 2 groups of x plus 1 looks like this, that must mean that it's equal to 2 x's and plus 2. But what you learn to do is, instead of actually saying 2 groups of x plus 1, you applied what's called distributive property. And every term in brackets must be multiplied by 2, just like when we were multiplying polynomials. Like if I gave you this question here, you'd learn that you had to multiply using distributive property to give you x squared plus 3x. So just like that, algebraically, I have to expand it using distributive property, and I end up with this equation. Now what's important to realize is that this 10 here is not doubled. It's not multiply everything in your equation by 2. It's only multiply whatever's in the brackets by 2. And once you have that, you can subtract your 2 from both sides, giving you 2x equals 8. Divide both sides by 2, and x will equal 4. But there is an alternative way to do it. And what we did is, if we had this x plus 1 and this other x plus 1, or 2 groups of x plus 1 equaling 10. If I was to take this and divide both sides into 2 equal groups, this side here will now say x plus 1 is equal to 5. If 2 groups of x plus 1 equals 10, then one group of x plus 1 must equal 5. And the way we can do that is by saying, instead of saying 2 groups of x plus 1, if I divide both sides by 2, instead of having 2 groups of x plus 1, I'll have 1 group of x plus 1. And from this point, I can just solve it using simple algebra. And x still equals the 4 that I got first. So when given questions with distributive property, you either divide both sides by the coefficient outside the brackets, or you can expand using distributive property. Your next question is a variation. The only difference is your coefficient outside the brackets is -2. So -2 groups of x minus 2. And we're going to clone this real quick. I'm going to take this over here. I'll clone it. I'll bring it over here. We'll solve it 2 ways. So the first way is to expand using distributive property. So -2 times x is -2x, and -2 times -2 is +4. So now we have -2x plus 4 equals -12. And I'm just going to solve using algebra. Get rid of my constant. Get rid of my coefficient by dividing by -2. And x will equal a +8. If I employ the other way, which is not using distributive property, but rather division first, instead of saying -2 groups, if I divide both sides by -2, I will have 1 group of x minus 2 is equal to 6. Just a constant in the equation, so I'll add 2 to get rid of the constant. And x will still equal 8. 2 pathways to get the same value of x. Both cases equals 8. Now your last 2 equations, what you're asked to do is, this is your constant. -2 is your constant. And actually, it's a -3rd of x, or a -3rd of x, or a -3rd of x. So all 3 of those things are what the coefficient is, because this negative symbol is still associated with the x variable. Okay, so the first thing I'm going to do is add 2 to both sides. And when I do that, I'm left with this -3rd of x right here. So when you're left with that, you need to make a decision. You could write it like this. You could write it like this. Or you can write it like this. All 3 mean a -3rd of x. And because all 3 mean the same thing, you're advised to put your negative symbol in your denominator, because it makes it much easier for your next step. So now that I have that, just bring this down here and attach it to your denominator. And that will equal 6. And then you're going to multiply both sides by -3 here. And x will equal -18. Okay. And that's the solution. X equals -18. Constant, coefficient. First thing I can do is get rid of the constant by adding 3 to both sides. And now we have this. So remember, it's not 5x, it's -5x. Equals 1. Because a -2 and a +3 combine to make 1. I'm going to divide both sides by -5. And some people don't need a calculator because they know 1/5 is equal to 0.2. And a positive divided by negative is a negative, so it would be -0.2. If you're not great with that, just take your calculator and go 1 divided by 5 is 0.2. And a positive divided by negative is a negative.